And I will try to make it possible within 10 minutes to present you two different topics. One is foundations and one is applications. They belong together, and I just would like to highlight some of the parts. We start with the foundations. We're talking about information diffusion in code review. What is code review? Well, code review is a discussion around a code change. We're not talking about the old one, the old-fashioned one, the ancient, heavyweight formal code inspections. We're talking about the more informal code reviews, as you've seen, as pull requests or pull merge requests in GitHub or GitLab. Why is code review so popular in the modern version? Well, information exchange is a key expectation towards code review. How do we know that? Well, there are different prior work we can rely on. They have found out that practitioners expect code review to spread information. Well, what have those three papers in common? Or there are actually more. They are all qualitative work. Not saying that qualitative work is less superior. It's just that the quantitative perspective on that kind of research is missing. And that's what exactly we would like to do. Our research objective is to provide a quantitative perspective to the qualitative existing results. And we would like to estimate the capability of code review to spread information as found out in prior work qualitatively. And we do that under best case assumption. What that means, I will come to that in a second. Therefore, we just approximate the upper bound of information diffusion in code review. So information diffusion is the spread of information. This is exactly. We have two research questions. In this talk, I will just focus on the very first one. How do we do that? Well, we do an in silico experiment. An in silico experiment is an experiment performed on computer and software. That's where the name comes from. And as for any simulation, it's very helpful when traditional experiments are simply not possible or accessible, too lengthy, too costly. I mean, you can imagine working with empirical data, with empirical industry partners, letting us do experiments with hundreds or thousands of developers in code review is probably too expensive. What I really love about simulations in general is they make assumptions very, very explicit. Everything what is in a simulation is explicit. This is great. I also love other aspects of simulation, so they are just great. The question, so if you have heard about Bayesian data analysis, this is actually, simulations are the counterpart for nonlinear systems, for example, right? Are simulations empirical method? Well, we could argue then probably more than half an hour from now, but we say yes. And we explain it in the paper. We just not say yes, we explain it in a very lengthy way. What is our in silico experiment doing? Well, the idea is very simple. We create a network of the individuals participating in the code review network, and we flood this network, meaning all participants spread the information as soon as they get in the simulation. And we start with seeding an artificial piece of information with each individual and see how far this information can spread, follow the path through the network. Just a short reminder, there is no actual information spread. It's a simulation. So there are no really traces, it's more the channels we are following. As for any simulation, also our simulation comes with a simulation model, and this is very important. As I said, it's very explicit. We model the code review networks with time-varying hypergraphs, which is super sexy. Have a look into our paper where we in detail explain everything and also validated our model, because any model is an abstraction of reality. Of course, you have to double check if the reality is still matched. We parameterized the simulation model with empirical data. So we went to different companies Unfortunately, two of them I'm not allowed, or I would love to ask them before I mention their name, but Microsoft already have agreed on that.
I can mention.
You can mention, yeah, you could mention, yeah, but please don't. So, and those networks have different attributes, and actually they are kind of on a logarithmic scale. So Microsoft is the largest one with 37,000 developers. Then we have one with around 2,000 developers and one with 400 developers or participants in a code review. The same goes for the code reviews, and they have different tools. Prior work suggested that the tool has impact on the quality of code review in terms of information exchange. They all have, we've split in a time frame of 4 weeks, 4 full weeks. That's very important because we found out in that prior work that time is a crucial, it's crucial to understand this kind of communication networks. How do we find now how fast and how far information can spread? Well, it's simple graph theory, it's the minimal path. The minimal path, however, has different notions in time-varying hypergraphs because we have the notion of time in. It can be the topological fastest or minimal, which is the shortest. You probably have all heard of that. And of course, it can be the temporal minimal, meaning the fastest or the foremost. We had to adopt the Dijkstra algorithm to come up with that. So this, hopefully this will be yet another paper, but this time in computer science, not software engineering. We have not the time to look through so many, through all the results. So that's why we look into only one research question. So how far information can spread? So how many other participants of the code review can be informed, so to say? And we just look in one number. This is a cumulative distribution function, and we just look at the median. 0.5 is the median. And you see for the smallest and the mid-size code review network, they have almost an identical distribution. The blue one is Microsoft, and even with 40,000 developers, on average, so like the median, more than half of the people can reach more than 30% of the whole network, which is incredible, I think. So what we learned from that, code review is very capable of spreading information. We also even found that for mid and small-sized code review systems, it's more or less an identical upper bound, what is possible, and it's relative to the network size. For the super large networks, and probably Microsoft is one of the largest we can found, we observe an absolute upper bound. This means it's a first qualitative confirmation of qualitative findings from prior work. And of course, we need further investigate that. This is, this is empirical work, but it shows just the upper bound, not what is actually happening. And of course, we would love to compare our findings in industry with open source, because I think open source works completely different from incentives and structural, organizational wise. So there's, I think it's very interesting to compare those findings. Very short on the matter. This was just a short view from our paper, The Upper Bound of Information Diffusion in Code Review. It's hopefully submitted very soon to EMSA Journal. The preprint is coming soon. And what I'm really proud of, please have a look into the replication package. It's wonderful design, following any engineering practice you ever heard of. It's just beautiful. Great. So now we understood that code review is very, very capable of spreading information. That so far so good. The question is now, so what? So we know that theoretically we have derived it, we have qualitative findings, we have quantitative, so what? Well, the problem is when a code review leaves the borders of a country, then it becomes taxable. So I know this is a hard break now. So we are switching now from code reviews to taxation, but I will tell you why and how this is important. And I will also tell you why this will make a lot of people a lot of headache. Because it's not only code review what is taxable, actually every exchange of intellectual property becomes taxable if there are more than two people from different countries are involved. So why and how? First of all, we need a very short introduction. I can make it in this time into multinational enterprise taxation. Let's have a look into this very, very simple example. We have two, we have Diffusion Group. It's a company making some software or enterprise service, whatever it is, sells it to a customer. And they have a subsidiary in Sweden, Diffusion AB, and the German Diffusion GmbH sells the software to the customer. So far, so good. But what happens when it comes to taxation? If we don't do anything, Diffusion AB gets all the profit, and the German tax authorities tax Diffusion AB in Germany according to their profits, and the taxation goes to Germany. What happens to Sweden? They don't see a cent or a krone. It's just they are left out in the code. And to overcome that, the OECD have developed guidelines, which became then law in the countries except for Brazil and North Korea, but it's international standard, either directly or indirectly, and they apply the so-called arm's length principle. The arm's length principle just tells you two associated enterprises like those two must operate as if they would not be associated. It's as simple as that. Meaning they need to pay Diffusion AB some price, the so-called transfer price, to overcome, to compensate the company as they would not associate. I mean, this is transfer prices from taxation perspective, so they probably do not pay it actually in terms of money, but this is from taxation perspective very important. And if Diffusion AB gets this transfer price, it can be taxed from the Swedish tax authorities, and they get their share from the profits because Diffusion have contributed to the software, and they have, for example, shared their code reviews, their bug reports, their requirements, and what else? Even their whole tools, components like Isan's work. That's the basics. So, but I think you can guess. Before I will even go further with that, but just as a very short explanation. So, is the problem a problem? So, are we talking now about a theoretical problem, which is nice to a researcher or just like me, but is it a real problem? So, what we have done is we measured the relative amount of code review which crosses the borders, which have participants with more than one country. And again, we used our modeling approach, which is the most beautiful paper in the world. And we see, in this case, we have, even before the pandemic, it was around 10%. And after the pandemic, it's skyrocketed. So 10% of the code reviews in this case we had, were crossing borders already and are actually taxable. So meaning also, this stands for collaboration. So 10% of the collaboration is taxable. And having a multi-million-dollar company, well, then 10% is not nothing. In particular, in software engineering, where we do produce products in the meaning of cars, physical products. Everything is IP. As I said, every exchange of an intangible property across the borders is taxable. And this applies to everything. Also, like thinking about Isan's work, think about components who are reused from another company. This is a part of licensing. You license someone else's code, even though it's internally within a company. And this is a general problem for all collaborative software engineering when there is more than one country involved. What are the challenges? We have not the time for talking through that challenges, but in our paper, we explained it, why and how those are the problems, because actually we don't know what is actually taxable in software engineering. So for code review, we have a slight understanding that it is from a practitioner's perspective and from a theoretical perspective for information exchange. And but it's very weak. And also the definition from the OECD is very weak regarding to what is proprietary information, for example. How to track those transactions? So, I mean, reuse, I mean, Isan, I'm absolutely sure you can tell us a long stories. Reuse is not trivial to track. I mean, there are tools for open source, but there are no or less tools for company internal reuse. And the last but not least, of course, if we would have solved the first one, what is the value of a code review? What is the value of a single commit? It can be huge. Think of the heartbeat bug in OpenSSL. This was one line of code, one single line of code, which failed the whole thing. And if OpenSSL would be a company, would have significant problems. It was one line. So you cannot estimate going by size. But on the other hand, look about the plot I showed you before, this one. It's about some 100,000 code reviews. So you cannot set people to evaluate every single code review. Was their IP transmitted or not? This is not doable. And in this field of tension we are currently in. So one option would be, can we not just change the law? No, unfortunately not. I mean, this is, first of all, a default standard for international taxation, and this is always hard to change. But from an ethical perspective, this is not possible, because what would happen if we would allow if we had not required the transfer price? What would happen? Every company in the world would go to the country with the lowest tax. This is exactly what would happen. So we would not have, for example, this is probably not an example for tax avoidance, right? But this is what exactly would happen. It would be probably not Sweden and Germany, but it would be Sweden and Germany and the Bahamas, where the corporate income tax is, I don't know, 0.1%. I'm just making up numbers, but it's not like the high tax countries I see it. They are producing the IP, but then it's shifted to a low tax country and hosted there. And it's not acceptable. And for physical goods, for tangibles, this is much more easier because you have always a shipping around stuff. But for IP, it's just a click in GitHub, for example. And then it's another team or another country. And this is super easy and super easy to cheat on. Is it a software engineering problem? Yes, it is actually. It is not a taxation problem because we don't provide the means and the tools for the tax authorities or for the head of tax and the companies, and we have not understood taxation in software engineering, meaning also the shift. What contributes to software and what doesn't? Can we ignore the problem? No. Probably you can, but you shouldn't, because it's an increasing problem, as we just showed in our exemplary case study. It's only 1 second. Or would you like to go for now?
Oh, sorry.
Because just this belongs to that. The title is Tax and Collaborative Software Development. It's an interdisciplinary research between legal and compliance and software engineering. It's already submitted, and if you cannot wait for the submission, here's the preprint for you to read it up. There's my talk in one slide. So I try to establish information diffusion is the spread among humans. We provide a quantitative perspective to the qualitative results. That code review is a very suitable tool for communicating and exchanging of information. And if information diffuses the borders of a country, it becomes taxable, and the taxation will make us all a lot of headache, no matter what your parts in software engineering you are in.